Okay, so thank you all for being here and for the interest in the RDGraph component of Fercar4EOSC project. I am Thanasis Vergoulis from OpenAir, that is leading the effort and coordinating the technical activities for the development of the RDGraph component. So I have a couple of slides that I would like to share. So let me share my screen. So this meeting, let me remind you that the idea is to help the use case representatives of the Fercar4EOSC project to be better informed about the RDGraph main functionalities that are part of the beta release, the MVP. And today we are going to provide some demos regarding this, and also some insights about the respective technologies. And we have also an open discussion to see to answer in more detail any technical questions that you may have, or to give in general any clarification needed. But before going further, let me give you a very high-level overview of what is the main aim of the RDGraph component. So the RDGraph is being developed based on the OpenAir graph. So to provide the RDGraph service, the various partners of the project that are building the various functionalities are building upon the OpenAir graph, but not the OpenAir graph as we knew it before the project kickoff. We are talking about an extension of the OpenAir graph that contains additional information that are project related. The most important of which is the inclusion of research activities based on raids.
Thanasi, sorry for interrupting, but if you share something, I can't see it. I don't know if I'm the only one, though.
Okay. Anyone else that has the same problem?
No, I can see a screen, which I think is yours.
Then
Yes,
sorry.
Okay.
But what screen are you sharing? Because
It's the Eduni agenda is currently shown.
So
It's the wiki. It's the wiki.
Yeah.
Sorry. I'm sharing the wrong screen then. Okay. Anyway. Now? Can you see?
Yeah, now we see slides.
Okay,
Yes.
apologies. Okay, so the main idea is that we get this extension of the OpenAir graph, and we keep only the content that comes from EOSC onboarded sources, and this produces the knowledge graph that is the basis of the RDGraph. And the RDGraph is not only the knowledge graph, but it also offers some services on top of it. And these are based on a group of discovery tools that are made available to the end users via a series of portals, the RDGraph portals. So very quickly, we have the main features that the RDGraph is providing is that the API and the dataset dumps that are given are compatible to the recommendations from the RDA's SKGIF group, which is a group that tries to provide guidelines for scientific knowledge graph compatibility and interoperability. We are providing functionalities for users to write queries in natural language and then translate them into SQL and other structured languages to query the graph. we offer some features that you can use, some impact indicators based on citation analysis that can help the end user to order or filter the results of a search that they are performing, and tailored recommendation for community members. Finally, we also have we are also going to provide some recommendations for missing grades and for missing grade contents. In any case, I will not go through this in detail. You can get a glimpse on the different functionalities that will be provided in the context of the project from the RDGraph team in the high-level roadmap in the wiki. And we have also created a table to facilitate sharing the repositories, the code repositories, the documentation websites, and the beta demo demonstrators of the various RDGraph functionalities. So this table provides this information, and of course you will see that the information included in the beta demo column is the one that will be presented to you today. Something quick to mention, from all these functionalities, one of them, the rate inference service, because of some implications in the fact that this is relies a lot on the RAID service, has not been included in the beta release, but the first version of that RAID inference service will be released at a later point. Of course, you can find also these resources in the link to the wiki that has been included in the slides. So without further ado, I will go to, I will provide you a quick overview on what to expect for today, and then I will give the mic to Claudio, who is the first to present. So the idea is that we are going to have very quick demos for each of the main components that are part of the beta release. They are going to provide you a 5 minutes demo for each of these functionalities. And after that, we hope that we're going to have a lot of time to discuss about Q&As on the components, but also about how we expect to get some feedback from the use case representatives, but also how we can go in improvements and further developments for each of the functionalities. So Claudio, the floor is yours.
Yes, thank you, Tanasi. Let me turn on my camera and just a moment to share my screen. Okay, you should be seeing my screen, not yet in presenter mode, right?
Yes, that's fine, Claudio.
Okay. So these 5 minutes will be mostly a presentation because the RDGraph data service, it's essentially plays the role as a prerequisite for the functionalities that in the context of WP3 are being built on top of it. So I'm going to illustrate how things work under the hood in order to guarantee mostly that the contents, the scientific contents that are part of the RDGraph are enough in terms of coverage to be relevant for the communities that we have in the project, and that they are constantly updated month by month. So the policy that OpenAIRE has for the update of these contents is to release a new version of the RDGraph along with the underlying RDGraph once per month. So every month we have fresh contents acquired from various types of sources, as you can see on the leftmost part of this slide. These contents, thanks to the processing pipeline that there is in place, form primarily the RDGraph, whose model is depicted here at the center of the slides. It sees at the center the research outputs, results declined into the 4 main categories that you see on the right, linked to data sources from which the content provide, to the project grants, so funders, the research organizations, and the communities. So this, on the logical level, a view from the moon represents the main model, let's say, of the graph data. This content gets processed thanks to a processing pipeline that indeed starts from the aggregation of these contents from the plethora of providers that are onboarded in EOSC, but also from large and known sources of contents like Crossref, DataCite, and so on and so forth. These contents, in parallel, the PDF of the open access publications comes in to support a data mining system that extracts the text from these publications and uses it to identify concepts like references to project grants and relationships among the objects in the graph, so among publications and dataset, among publications and software. This content then get disambiguated thanks to the duplication algorithm, which is a crucial part of the process, as it is important to, for statistical purposes, to avoid counting more time the same deposition. An example is the preprint and the postprint. If you want to run research assessment, you have to take these aspects into account. Then we have another part of enrichment. It's mentioned here as by inference because it leverages on the topology of the graph itself to infer properties from other nodes that are linked to publications, for example. Finally, the graph gets materialized into various forms. Opener services, as you can see here, like Explore, Connect, the Observatory Monitor. It's available from the Opener APIs, as we shall see later, and gets materialized as the RDGraph in the context of this project. So what we are going to do is to essentially continue, of course, and the existing operations to keep the contents up to date, to find room to accommodate the rates, which is going to be, at least from the modeling part, something not particularly hard work, because at least in terms of concept, on the conceptual level, rates are indeed a sub-graph per se. So they will find proper room in the graph. But this, as Tanasi mentioned, this work is going to be addressed in a later stage. We already produced community-specific datasets, subpart of the graph, that are supporting the activities in the task 3.3. So to build the natural language search and the recommender system. We already started to develop the workflows for the regular generation of datasets that are related to particular community profiles. And this is done implementing the specification from the RDA Open Science Graph for Shared Data Group. We have a first version of this specification, and we already provided first version of the conceptual mapping from the internal graph representation towards this data model. So we mentioned the rates. These will be available also through the APIs. from which the graph is served. And the same APIs actually were already extended to support sorting and filtering based on the citation indicators that are now being already calculated as part of the graph provisioning pipeline. So I wanted to quickly showcase these on the graph documentation website. So this is the, if you go to, not sure if you can see the full browser, but I cannot. If you go to graph.openair.eu, under resources and APIs, you can reach this page. And in the selective access section, it's possible to sort results by citation count, impulse, influence, popularity, which are the most recent additions in this section. At some point, when rates will be available in the contents, we are going to extend the parameters here to support them as well. And I think this covers my part for now.
Okay, thank you, Claudio. In any case, Serafim will provide more about the impact-based search in a later slot. So with that, let's move to the next speaker, which is George Katsogenis, about the natural language search.
Thank you, Thanasi. Give me a second to share my screen. Okay, so I have a few slides just to give everyone an idea about what the NL Search service is. So essentially, this service will allow users to query the RDGraph using natural language, so they can come and ask a question and they don't have to worry about the structure of the data, what's happening underneath. Simply, they will ask something in English, like they're asking a person, and our service will translate their natural language query into a structured query in SQL specifically. And then this SQL query can be executed over the RDGraph, and we can then return the results to the user without them having to see what's happening underneath. And just to bring you up to date about today's demo, so up until now, we have trained a first neural model on a general purpose text-to-SQL dataset. That means that our model has not seen examples specifically from the RDGraph, which is a future step to improve its performance. We have connected our service to a local instance of the RDGraph, and right now we are the demo we are showing uses sample communities and not the actual communities of the project, which will be added later on. And finally, we will see a proof of concept demo to give you a feeling of what this service can do and to allow everyone to play around with it and help its development. And just a few words about future work on this service. We are planning on training our models specifically for the RDGraph, and this will definitely improve performance because it will help our neural model to learn the specific schema that the RDGraph has and the data that is present in the RDGraph. We will work on automatically correcting possible errors. Since we're using a neural model, it is not possible on its own to produce a good prediction all the time, but we are working on adding additional mechanisms that will guarantee that we will have an executable SQL all the time. And like I said, another thing we want to do is update the RDGraph instance so that it actually works with the use cases of FAIRcore. So with that said, I would like to show you a few examples. So this interface is pretty simple and just focus on what we can actually do. So for example, we can ask the service show information about authors whose first name is Yanis, let's say. So what happens when I press search? First, our neural model will translate this question into SQL queries. And then we will try to execute these SQL queries. And as you see in this example, the first prediction can actually be executed. So we will see the results of this query right here. Obviously, it's not very beautiful, but it's mainly for demonstration purposes. And since we're using natural language, we can ask pretty much whatever we want. The only limitation is if this data is actually available in the database that is underneath and our system's performance. So another example before wrapping it up. Let's say we want to learn how many authors are stored in the database. We can ask that in natural language. Again, our system will translate this question into SQL, and it will try to execute it. Again, this example is executed correctly, and we see that the RDGraph, or at least the dump that we have right now, actually has a lot of authors stored in it. So yeah, that pretty much wraps it up. You can see that a lot of SQL queries can be generated, and this will help us improve the system's performance. And like I said, we will work on guaranteeing that no matter what you write here, you will also always get a query that can be executed and some results returned. So that sums it up for the NL Search service. Thank you very much.
Okay, thanks, George. So with that said, we can move to the next demo, which is the impact-based search to be presented by Serafim Hatzopoulos. Serafim?
Yes, hi. Okay, you can see my screen right now, right?
Yeah, yes, but not in presenting mode.
Okay. So it should be fine now, right?
Yeah.
Okay, so hello, I am Serafim Hatzopoulos, and I will briefly present the component that implements the impact-based search functionality. So the main idea here is that we want to estimate the scientific impact of an article by analyzing how many other articles are talking about it, or how many other research products in general. So the intuition is that the more talk around an article, the higher the impact that it has. For example, one very popular scientific impact indicator is the citation count. That just counts the number, the times an article is referenced by other works. This is a very well-known impact indicator. It is used in numerous platforms. In an article that we published some years ago, we identified that there are some distinctly different aspects of scientific impact. For example, a PhD student that starts studying about a specific topic may want to identify the most fundamental works in that field. So he or she is interested about the overall impact, or as we call it, the influence of the works in this topic. On the contrary, a well-established researcher or a professor may be interested to identify the impact of articles right now, and we call it the popularity of a research result or a research product. So these are the two of the 4 impact indicators that we calculate in this context. And the other ones are the traditional impact, the citation count, as we said before, and the impulse, that is essentially how much attention an article has received the first years after its publication. So we have implemented a dedicated workflow in the RDGraph provision process. That is essentially the open provision process to calculate this set of 4 impact indicators. As the first step, we have extracted citation relations from the graph, and we have constructed the citation network, on top of which we calculate those impact indicators with an open source Spark library that we have implemented. So the idea is that we enrich the graph. We calculate those impact indicators on top of the citation network, and then we enrich the graph with the calculated impact indicators, and we also publish them as a separate data set on Zenodo. So those impact indicators are then documented in the RDGraph documentation website, and the code that we use to calculate them is open source and can be found on GitHub. So we offer 2 main functionalities. The first one is the impact-based ranking of the results, and you can use both the API to search for research products and rank them by a scientific impact indicator. As we can see here, we can specify the sort by parameter and then popularity descending. And this functionality is also available through the RDGraph portal. We can sort the search results based on one of these 4 impact indicators that we said before. And we can also see a thumbnail that it says we have 1,000 citations, and it's on top 0.01% on the popularity indicator. And there is also a second functionality that allows filtering of the results based on predefined classes. For example, we can pass here the popularity parameter in the API and specify that we want only the results that are of class C1. These are predefined classes. The C1 corresponds to the top 0.01% in this specific impact indicator, and these classes can be found also, of course, in the documentation website, what they correspond to. I think that this sums it up. We can also see this live demo here. This is the RDGraph portal, and if we search here for, let's say, semantic search, we get back the results. These right now are sorted by relevance, but we can sort them by citation count, popularity, influence, and impulse. We can choose to sort them by popularity, and for each result, we can see here a summary of the impact in these 4 dimensions. So yeah, that's basically it.
Okay, thanks, Serafim, for your presentation. I think that we can also move to Stavroula Eleftherakis. she will present the community recommendation profiles.
Hi, everyone. Just let me fix everything. Okay, it's from... Okay, so I guess that you all can see my screen, the presentation. Am I right?
Yep.
Okay,
Yes.
great. So I'm Stavroula Eleftherakis from Athena Research Center, and will demonstrate to you community recommendation profiles, a task of the FAIR Core for EOSC European project. So before starting with the demo, allow me to give a few definitions so that to bring everyone on the same page. So what is a community? A community is a collection of data that represents information about a particular research field. So for our mathematics use case, this could be the field of statistics, for example. From a technical perspective, communities to us are subgraphs of the RDGraph that connect similar research products together. This could be books, that could be publications, data sets, etc. So, and what a community profile is, it is a realization of this collection of information regarding a community, essentially a web page. And community profiles are important for a number of reasons. Okay, they help a community to organize things around. It allows you to keep track of what is new in your research field of interest. It improves collaboration between community members, and of course, it can give you recommendations of what to read next. And this is particularly the task of which we as a Data Lab team in Athena Research Center work. So what we have done so far is that we extracted citation information from the RDGraph, and we collected the number of times an author cites a particular research product, and we used those data in order to train two recommendation services, essentially. The first one, the author to item recommendation service, is for offering personalized recommendations to authors. So essentially, given your history of citations, we utilize it to give you recommendations and answer this question based on your preferences, what should you read next? And then we have the item-to-item recommendation service that does not give personalized recommendations. So based on the entire information of a community, we find similar research products together, and based, for example, on one publication, we can give you related ones that you may find interesting. So, and let me now show you the demo. So forget this page for the time being. So this is the main page of community recommendation profiles. This is a temporary UI because, as you can imagine, at the end of this project, every tool that each one of us is presenting today will be together in a single page. So the user first has to choose from a community. We offer, for the time being, 4 communities, each one touching a different use case of this project. For this demo, I will choose the first one that is extracted from the ZBMath database for the mathematics use case, and we have isolated the community of functional analysis. So it contains all information, publications in functional analysis. And then from here, you can write down or try to find your ZBMath author ID. For this demonstration, I will choose this particular because I'm familiar with the research of this person. And so the ZBMath ID, this is the ZBMath ID of Eleftherakis George, that is an assistant professor at the University of Patras. And here you can see a list of 10 recommendations. This is the default number of recommendations. Of course, we can increase it. And we have 10 recommendations of publications that this individual may find interested. As you can see, most of them are in C-star algebras. And just to show you that this works and it works good, I have opened here the Google Scholar profile of this researcher, and you can see that C-star algebra is indeed a keyword, let's say, in one at least of his publications. And another thing is that if you see over here in the 9th recommendation, you can see that it is recommended the publication of Paulsen, one of the authors, and you can also see that the most cited publication of this individual over here is with Paulsen. So the recommendations are relevant based on the history of Eleftherakis George. Now, let's say that I want to see a few details about one of those 10 recommendations. I can press, for example, the button here. And I can see a few things from the database, the authors, the publication year, keywords, if it is a journal paper, and yes, and we can see on our left hand here that we have the other service, the other recommendation service, the item-to-item service. We can see the top similar publications related to this one. And as you can see dynamically, when I change, I click to see the details in one of those, this list of top similar publications changes. And I can go back, and pretty much that's the demonstration of the community recommendation profiles. Thank you.
Okay, thank you, Stavroula. So the last presentation, last but not least, is about the RDGraph portals. And now, because also it was mentioned by Stavroula, let me say that by the end of the project, every functionality will be incorporated in these RDGraph portals. For now, we have a couple of them already included, but by the end, we are going to have everything inside these portals. For the time being, of course, you can access its functionality using the respective UI that is included in the table that presents the demos. So with that said, Konstantina, can you present RDGraph portals?
Yes, of course. Hello. Let me share my screen. Okay. All right. I think you can see now my my presentation, right?
Yes, we can.
Yes.
Okay. Thank you. Okay, so hello, I am Konstantina Galouni. I'm going to present you the RDGraph portal as it is now. It is already set up as a beta instance in beta.rdgraph.openair.eu, and is an easy. It is built on top of the RDGraph, and it is an easy access point on the entities and the relationships of the RDGraph. The homepage and the colors of the portal are customized to have similar look and feel. Sorry, accidentally pressed. To have a similar look and feel with the main website of FAIRCORE for EOSC project. So the main functionality of this portal is the search functionality, for which we are offering simple and advanced search pages. In the simple search forms, you can search by keywords or by persistent identifiers, such as DOIs, PMCIDs, etc. And you can search among the 4 main entities of the RDGraph, which are research products, including publications, research data, research software, and other research products. The projects, services, including data sources and other services, and organizations. On this page, we have a variety of filters on the left side of the page that users can click on to narrow down the search results they prefer. The response is customizable in terms of sorting and in terms of selecting the number of results per page. And the search results are also downloadable. The advanced search page looks similar to the simple search page, but it offers a more advanced search form and gives the ability to the users to express more complicated queries to search. One major implementation we had for the FAIRCORE for EOSC project is introducing the 4 new impact-based indicators as sorting options in the search results. Serafim also mentioned that, as well as Claudio. And as you can see here, for example, we have selected citation count, and we can see that we have the search results sorted by descending order in terms of citation count. And for each result, we can see down here the number of citations and in which class of the popularity, influence, and impulse this result belongs. Also, as mentioned by Claudio, we have this implementation also available in the API. And for example, users can query by sorting research products either by one or more sorting options. For example, I have here a query expressing to the number of research products sorted by citation count in descending order and by popularity in descending order. In the API, we also offer the ability for filtering with impact-based indicators, again, with one or multiple. And for example, here we have the query that expresses get the research products that belong at top 0.01% or 0.1% in terms of citation count, and at top 0.01% in terms of popularity. As Serafim also mentioned, we have 5 classes for each one of them that we can query. You can see more at the graph.openair.eu portal. Another implementation we have added in FAIRCORE for EOSC is the software heritage persistent identifier. Users can search by adding in the simple search form the software heritage persistent identifier, or by selecting in the advanced search form the PID field and adding there the persistent identifier. And they can see in the results, in the metadata, the software heritage ID. Last but not least, we have added the services. We have introduced the services as a main entity of the RDGraph for which we can search. And the services include, as I already mentioned, the data sources and other services. When selecting one of its search results, we navigate to a detailed page, which is tailored for each entity, meaning that the metadata presented are tailored for regarding we see a publication, or we see software, or we see, for example, a service. And we see an overview of all the available metadata and the relationships that belong in the RDGraph. We see multiple statistics, metrics, and impact-based indicators. For example, we can see impact-based indicators and metrics on top right of the page, as well as in a tab called metrics for more detailed for more details. And we also offer a set of actions on top of the page, for example, to download the full text or view the available versions, share this publication in the social media, and others. Thank you very much. I can also, if you prefer, I can also quick demo all that. I just preferred slides to be more structured. And for any questions you have, you can contact me at kgallouni@athenarc.gr or Katerina Iatropoulou at kietrop@athenarc.gr. Thank you very much.
Okay, thank you, Konstantina. Also, if you didn't notice, for example, Seraphim provided a live demo that was based on the RDGraph portal because, for example, the impact search has been already incorporated there. We have a couple of minutes if you want to show anything that is of interest. Otherwise,
yes,
we
of
can.
Course. Just a second to prove what we already have showed in the slides. So this is the beta RDGraph.openair.eu portal. We can search either by adding a keyword or by simply selecting the search button. Here we can see the search results with no keyword. It is just all the set according to relevance. We can search, we can sort by the 4 impact indicators. Let's say I select citation count. As I already showed, we can see that we have the most citations, the result with most citations first, and we go in descending order. I have already opened in order to search. If we click on this result, we can see that we have the citation count, then the impact-based indicators, citation popularity, influence, and impulse here. We have the metrics here with more details, as you can see. We have multiple relations. For example, we have 11 research products that are related to this specific publication. And for the software heritage ID, we can see that we can see the this persistent identifier in the metadata. I just copied it to go back here in the search page. I will paste here the persistent identifier. Yes, it's not open access. Oh yeah, it was. And we can see that here we are. We can see it by searching, or we can use the advanced search page. We can select PID. And again, if we search, okay, sorry, I put an extra space in front. So this is it. And as you can see, sorry, I'm a bit. And as you can see here, we have the services as a main entity for which we can search, and we have data sources and other services.
Okay.
I think this is it. Thank you very much.